Welcome. All right. So we're going to continue our video about graphs of sine and cosine and tangent. And this video is going to be example video where we look at solving a problem, a couple of different methods. So I guess we'll just start. We'll dig in. All right. So we're interested in finding all the values of x where sine of x equals cosine of x. So what inputs would you plug into sine and cosine where you get the same answer? So we're going to solve this three different ways. The first way is by thinking about the unit circle definitions for sine and cosine, and then we'll look at an algebraic method for solving it, and then finally we'll look at the graph of these two functions and compare them. Okay, so the unit circle method is when we think about the unit circle, we know that sine is the y-coordinate and cosine is the x-coordinate for the angle x. So I'm using x now instead of thetas to try to bring in the fact that we want to start thinking of these trig functions as functions of a variable. And when we typically describe functions in math, we use x to denote the input of the function. So we're going to say x is our angle, x is the input, sine of x is the y-coordinate for the point on the unit circle, cosine of x is the x-coordinate for the point on the unit circle. So here's my handy-dandy unit circle. I've got it in radians over here. This question now, we can think about it as what angles on the unit circle are the two coordinates the same? The x-coordinate and the y-coordinate are the same. So when is the sine equal to cosine? When are they the same value? So if we look at the unit circle, we want to find these points right here. So right here, we know that one's root 2 over 2, root 2 over 2. And down here in quadrant 3, they're also the same, but they're both negative. We've got negative root 2 over 2 for the x, root 2, negative root 2 over 2 for the y. So it looks like our answers are going to be pi over 4 and 5 pi over 4, and then everything that's coterminal with that. So, I mean, we can go, if we were to go back in the negative direction, let's think that way. So we've got pi over 4, this angle, we've got 5 pi over 4, this angle, we've got 9 pi over 4 if we go around again, and so forth. If we go in the negative direction, this would be negative 3 pi over 4, and then this one over here would be negative 7 pi over 4, etc., etc. So how can we describe all of these answers? Well, if we want to describe all of them, we look for a pattern between answers. We look that and see the pattern is pi over 4 plus any multiple of pi. So if we were to basically start at pi over 4 as the first answer, if we add in a multiple of pi, we get to the next answer. If we add another multiple of pi, we get to the next answer. If we add another multiple of pi, and so forth. So this describes all the possible x's where you take the sine of x and the cosine of x. Okay, so let's think of another method, kind of an algebraic method for solving this. It also is going to rely on the unit circle and our understanding of that. So starting off with the equation, we want to find x is 2, sine of x equals cosine of x. Now let's try to do something to kind of morph this into another question. So another question we could turn this into is a tangent question. So let's divide both sides by cosine of x. So we're going to divide the left side by cosine of x and the right side by cosine of x. And you're going to see what happens when we do this. The right-hand side, cosine x divided by cosine of x is 1. And the left-hand side, sine of x divided by cosine x, well, that's equal to the tangent of x. So now it's asking, where on the unit circle is the slope 1? And that's another easy question to answer. What x's, what angles would you plug in and get a slope of 1 out? And we remember that the slope of 1 happens at pi over 4 and also at 5 pi over 4. So we get the same set of answers by thinking about it now in terms of slope. So x equals pi over 4 plus any multiple of pi. Okay, so this is kind of an algebraic way of getting there. We still have to segue into the unit circle to think about when is the tangent 1, but this method works just fine, turning it into a... Okay, then the last method that we're going to do is a graphic approach to this. And this is going to, again, kind of reinforce the graphs of sine and cosine for you guys, as well as thinking about what does it mean for two functions to be equal graphically. So we're going to graph sine of x and cosine of x on the same axes so we can see where these two functions overlap. So where do they intersect each other? When we find the intersection points, that's going to tell us the x's, the inputs, where they have the same outputs, which is what we're looking for. This means the outputs are the same. We're trying to find what x's, what inputs, give us the same outputs. So we'll start off with sine of x. I'm going to graph sine in red, because why not? And then we'll do cosine in blue. So sine of 0 is 0, sine of 2 pi is 0, sine of pi is 0. This is my method for graphing these functions, is to start at... So now that we have an understanding of the graphs a little bit, I'm going to show you a kind of faster way to graph them. I don't want you to go straight to the faster way because I would like you to think about what's happening in between. But we'll just plot these 5 key points first and then the in-between points to kind of fill in the gaps. So sine of 0, pi, and 2 pi, those are all equal to 0. At pi over 2, the sine is equal to 1. So I'm going to plot that up. Pi over 2, 1. At 3 pi over 2, the sine is equal to negative 1. Oh no, 3 pi over 2, it's negative 1. At pi over 6, the sine is 1/2. And at 5 pi over 6, it's 1. At 2/3, it's about 0.866. So we're going to go up to, or 1/3, it's about there. And about there. Okay, so we're going to have a nice little 3 pi over 2, 7 pi over 6, it's negative 1/2, negative 1/2. 11 pi over 6, it's negative 1/2. And then it's about 0.866 for 4/3 here. It's curve. So there's the sine function, that's sine of x. Now we're going to go ahead and graph cosine. Cosine is 1, 0, 1. 2 pi, it's at 1. And at pi, it's at negative 1. Pi over 2, it's at 0. 3 pi over 2, it's at 0. And then we have the in-between points. Pi over 6, it's about 0.866. Pi over 3, it's about a half. It's exactly a half. 2 pi over 3, it's negative 1/2. And then 5 pi over 6, it's negative 0.866. Right there. 7 pi over 6, negative 0.866. 866. 4 pi over 3, negative 0.5. 3 pi over 2, it's 0. 5 pi over 3, positive 0.5. 11 pi over 6, like this. Okay, so let us look graphically for the answers to our question. When is the sine equal to the cosine? So what we're interested in are these intersection points. I'll circle them. Where the two graphs have the same y-coordinate. So where the y-coordinates are equal to each other. And that is where sine equals cosine, because the answers are the sine and the cosine respectively. So we want the x-coordinates where these intersection points occur. If we want to find the y-coordinates, we can as well. The y-coordinates in both cases are, well, in this case it's root 2 over 2. Positive root 2 over 2, and in this case it's negative root 2 over 2. And so we just have to remember, you know, if we graph this thing very precisely, we could see where they intersect specifically, and or we just remember, okay, yeah, we know that those are at pi over 4 and 5 pi over 4 respectively. So here's pi over 4, and over here, this is at 5 pi over 4 pi. Okay? And it should make sense with how we've kind of sketched this out. We have pi over 2 is right here. This is pi over 4, halfway to pi over 2. This is 3/4 of pi right here, 3 pi over 4. And then we have 5 pi over 4. This is 4 pi over 4. This is 5 pi over 4, 5 pi over 4, 6 pi over 4, and that's 7 pi over 4 over here. Okay. All right. So we're going to get the same set of answers. We're seeing this answer, pi over 4, this answer, 5 pi over 4, and we're going to end up having the same set out of this. And so forth in both directions. Okay, and so we could use a graphing software to do this and look for the intersection points or what have you. So I'll just do that very quickly. I'll open up Desmos and we'll see kind of how you can use Desmos to find these intersection points. It's very, very intuitive and easy to find intersection points of graphs on Desmos. So and in this case, we're interested in the inputs, the x coordinates for these intersection points. So let's go ahead and open up Desmos. Desmos. Okay. So we're going to graph sine of x. Whoa, I'm in caps lock land. Sine of x, cosine of x. Do we have the same colors? I think red was sine and cosine was blue. Fantastic. All right, we're matched up. Pi over 4 and 5 pi over 4. So I'm just going to click on each point where the graphs cross each other. And that gives us the set of x's where the sine is equal to cosine. Okay, so if we just highlight again, that's pi over 4 and 5 pi over 4 and 9 pi over 4. And if we go backwards, negative 3 pi over 4, negative 7 pi over 4, negative 11 pi over 4. So that's that set I was describing earlier where we've got pi over 4 and a multiple of pi. So any multiple of pi added on to pi over 4 gets us all of these numbers. Okay, so there's an infinite number of x's, an infinite number of answers. You know, I can zoom out and we'll see that, you know, this function goes on forever and ever. So we could, you know, negative 31 pi over 4 would be an answer. Negative 27 pi over 4 would be an answer, and so forth. But all of these are kind of generated from x equals pi over 4 and then add a multiple of pi to that. Okay, so so yeah, that's how you can use a graphing software like Desmos or your graphing calculator to find these intersection points. It's really as easy as plot the two functions, type them in, and then just click on the graph where they meet, and it tells you their intersections. So again, remember the other coordinate for the intersection points, that's the actual answer to sine or cosine. So in this case, the sine and cosine are both 0.707, square root 2 over 2. In this case, they're both negative square root 2 over 2, so forth. Okay? All right, so that's kind of using a lot of different tools to solve this problem. One is sine equal to cosine. Just thinking about it in terms of the unit circle, solving it or manipulating it to be another kind of problem using tangent, and then looking at the two graphs of these functions and finding where they cross each other, where they meet. And the bell rang, and that's done. I'm done with this video. So perfect timing. I'll see you guys next time in class.